Okay, this last part, or really there's two more examples here, but the last part is actually using what we now know about our calculator to go through and answer other types of problems. So in example 5, it's saying to find theta in degrees and then find the given function of theta. And if you notice, there's a couple of ofs there. Do not clear your calculator between steps. That's because we're going to use our second answer feature of the calculator. And it says confirm your answer by sketching the angle and using the definitions of the 6 trig functions. We're not going to do that on every one, but on at least one of these we'll do it. So what it's saying is find tangent of theta if sine of theta is 2/5. Now you're going to start with what they're giving you. They're saying if sine of theta is 2/5, we can use that to find theta, and then we can take tan of that theta. Okay, so how would we find theta? What would be that step? Right, we'd go arc sine of 2/5. Okay, and then once we have found that, we are going to take tangent of that theta. Okay, so let's type this in. First, let's make sure we go back and we're in degrees mode. Now, since we're actually doing 2 steps here, it wouldn't really matter in the end that we went to degrees mode, but just so we're all on the same page, let's make sure we're in degrees mode together. Okay. So let's take arc sine of 2/5. Okay, so second sine, 2/5. Okay, and that's the angle. They're not asking us for this angle, but this is important. And then we are going to take tangent of that angle. So it's tangent, I want you to do second decimal. I don't want you to retype that number in because you won't have the same accuracy. You have to round at the end, but you do not have to round in the middle. Okay, let's round to 3 decimal places. 0.436. Okay. Alright, so that is my answer. That's the approximation of my answer. To do this exact, we can actually do this exact. We need to draw a triangle. Okay, and we need to mark our theta somewhere. I'm going to go ahead and mark my theta down here. Now, if they tell me that sine of theta is 2/5, that means that the opposite of theta is 2, and the hypotenuse is 5. And we could do Pythagorean theorem to find the missing side, and this we've done before. Okay, root 21. From here, I can find anything I want about this theta. Okay, here we're finding tangent of theta in this example. So tangent of theta would be opposite over adjacent. Okay, so my answer exactly would be 2 over root 21, which simplifying would give me root 21 over root 21, and this would be an exact answer. Now, so far, my 2 answers don't look alike at all. Alright, but remember that the blue here is an approximation. Okay, so let's go back and type my exact answer into the calculator. Make sure you close that parenthesis when you're done square rooting. That's important. There we go. Get the exact same, and notice that all the way out here, it's the exact same. So if on a problem like this I was asking you for the exact value, you would do it this way in red, drawing the triangle. If I asked you for an approximate answer, okay, you could do this here in blue. Notice that in red, we have no idea though what theta is. We know it's an acute angle, but we really don't know what it is. In blue here though, using the calculator, you can find an approximation for theta. Okay? Let's go ahead and do part B. I'm going to switch back to blue here. Alright, and I'm not going to focus too much on the confirming it part. I want to focus more on the calculator part since that's the new stuff. Alright, now to find this theta, we need to take arc cosecant of 7/4, which would be the same as arc sine of the reciprocal of 7/4. Now don't go all wacky and try to do 1 divided by 7/4. Just flip the fraction. We only did the 1 divided by before because we didn't have a fraction to flip easily. Okay, So arc sine of 4/7, not 7/4. Okay, this will give us our theta. All right, how are we going to find secant of theta? Okay, secant of theta is going to be equal to 1 divided by cosine of that theta. And we can do all of this in our calculator. Let me clear that out. So we want to go arc sine of 4/7. Okay, there's our theta. And then we want to do 1 divided by cosine of this theta. We get 1.219. And I'm writing an equal sign here, but really this is an approximation. Alright, just to make sure, if you want to get extra practice confirming these all with a triangle, I'm going to go ahead and give you the exact answer you should come up with, and that is 7 root 33 over 33. Okay, and you can do that on your own for extra practice if you'd like. Okay, let's move on to example C, and let's start with what they give us. Cotangent theta equals 3/5. At this point, if you think you can do this one on your own, pause it and try it, and then watch my solution. Alright, so theta would be arctan of the reciprocal of 3/5, which is 5/3. That would give us our theta. And cosecant of theta would be 1 divided by sine of theta. Hopefully by now you're getting a lot more used to the 1 divided bys. You know where they're supposed to go and why. Okay, so arctan of 5/3. There's our theta, and then 1 divided by sine of that angle, 1.166. That's our approximate answer. If you are confirming these with the triangle, or if you just like the triangle better, that's fine. Your answer exactly would be root 34 over 5. Okay, last problem. Now, this looks like the others, but there's one thing I want to point out, so don't fast forward if you're thinking you got this. I don't want you to fast forward just yet. Okay, this is saying to find cosine of theta if secant of theta is 7/3. If you just look at a problem and then you just go straight forward, a lot of times you're going to end up doing extra work, okay? Although that would be fine in this problem to go ahead and do this the same way we've done the others, but let's just think logically for a second. Cosine, secant, they are reciprocals of each other. The theta in both of these cases is the exact same theta, alright? So let's think about, if secant is 7/3, what would cosine be? 3/7. Exactly. Now this might, or it could definitely change if we put a negative in front of here, and that's going to come up in a future lesson, but you don't have to worry about that at all for right now. Okay, but I don't want to tell you something's always the case when it's really not. Alright, let's move on to the last part. It says find the measure. Okay, let's look at example 6. Find the measure of theta correct to 3 decimal places. They're giving us 2 pieces of information. The first piece looks like what we already know. So if we look at it, cosine theta equals 0.752. And so we know that that means that theta equals arc cosine of 0.752. Alright, great. Well, this may or may not be fitting the inequality that they give us. Let's go ahead and plug it in, because if it does fit this inequality, then we don't have to do anything else. Okay, I'll go ahead and ruin the surprise for you, and I'll tell you that it's not. Okay, so I've already had this typed in, and here we go, 41.236. We're in degrees mode. They didn't. They told us that by telling us this. Okay, they didn't say it in the direction, but they told us it was between 270 and 360. All right, so 41.236 degrees. Okay, this is obviously not between 270 and 360, which is quadrant 4. All right, this is actually the reference angle. Okay. So let's draw this. Okay. Oh, sorry. Let me back up. Quadrant 4. They're telling us our reference angle is 41.236. And what they're asking us to do, let me put this in blue, they're asking us, well, what is the angle between 270 and 360? What is the angle in standard position if the reference angle is 41.236? We've seen problems like this before. Well, how are we going to do this? Just look at what makes sense by drawing it. Don't think back to a rule you've memorized. Yeah, we're going to subtract from 360 would give us our answer, and I'm going to show you an easy way to check your work. That way, if you've made any mistakes, then you'll be able to check them. Oh, 236. Okay, so let's do this in our calculator, and I am not going to, I'm going to always use answer until the very end. I'm not going to round in the middle of the problem. So 318.764. This is my answer. And we can easily check this. First off, is it between 270 and 360? Okay, it is. Next thing, when I take cosine of this, does it equal 0.752? Well, that's easy enough to check. Let's hit cosine, answer. There you go. That's how you know you're right. Okay, let's do this other example. Alright, here we have secant of theta equals negative 5.127 if it's in this quadrant. And this quadrant on this example is quadrant 3. And I'm going to go ahead and start by drawing the picture on this one. Because if we're clever, we save ourselves some work. Okay, so before I even start, does it make sense that my answer here is negative? And by answer, I mean that this decimal is negative, that secant is negative in this quadrant. Yeah. Okay, so when I'm trying to find this reference angle, if I keep that in mind, I'm going to simplify the process that's going to help me. Okay, so I want to show you two things. First off, I want to show you how to find theta. And if you're just looking at this and thinking of how we've done the problems before, we would do arc cosine of negative 5.127. Now, we haven't had any where you've put a negative in there, and there's a reason for that, and I'll show you what happens. Okay, so if I type in arc cosine negative 127. I forgot my 1 divided by again. So let's go through and let's put that in. Sorry about that. This is the nice thing about the error. It kind of helps you find your mistake. There we go. Okay. Here we go. So 101, ooh, that's not acute. This is not giving us our reference angle. It's giving us a positive answer. This has to do with something called restricted range, which is another lesson for another day. So what's going to simplify your life is if on these types of problems, you just drop the negative. Now remember, I told you that there's a way to check your work at the very end. So don't stress that this is going to cause your answer to be wrong, because you'll know at the very end. Alright, so 101 is just your reference angle in a different quadrant. This is in quadrant 2, where cosine and secant are positive as well. We really want our reference angle to be acute. That's going to help us make the next step easier. Alright, so 78.753. And let's fix this mistake as well. So this was supposed to be 1 divided by negative 5.127. If you caught that while I was working, good job. That means you really understand that. Okay. Let's write ourselves also a little note that we dropped the negative. Okay. Because we're going to figure it out when we get to what quadrant we're supposed to be in. So write something like drop the negative. Something in your notes that help you remember what to do. Okay, we're going to do it again in this one, so we'll get some extra practice. Alright, so that reference angle in this problem is 78.753 degrees. Okay, so that's my angle right here. Okay, 78.753. What I want is the angle in standard position. I want an angle between 180 and 270. So what do we need to do? From 0 to right here is 180. We need to go 78 degrees past. Yeah, we need to add to 180. That's what makes sense here. So 180 plus 78.753. When I do this, notice both that I get an answer between 180 and 270. And if I take secant of this, and the way I would take secant is to do 1 divided by cosine of my answer. Notice that I do get the negative 5.127 that I started with, so I know that my answer is correct. So 258.753 is my final answer. Feeling pretty confident with this? Try to do the last one on your own. Pause it, see if you can do it on your own, and then watch the solution. Okay, here theta. Remember here, this first step is just finding the reference angle. So our theta here is we're going to drop the negative, and we're going to do arctan of 1 divided by, since it's cotan, and I'm not going to do the negative, just 0.625. Okay, and that's just because this is an intermediate step. It's going to make it easier to find the reference angle. Okay, once we find the reference angle, we're going to put it in its right quadrant and figure out what the angle in standard position should be. Okay, so let's clear that out. And arctan of 0.625, 32.005. Okay, that's my reference angle. I keep forgetting to do that 1 divided by. Let me back up. I apologize. Arctan of 1 divided by 0.625. There we go. 57.995. And that's degrees. Okay, let's draw this. This is in quadrant 2. Remember, our reference angle is always with the horizontal, so 58 degrees approximately right there. What we need to do is find the angle in standard position, and in this case, again, it's not like you have to memorize these rules. You can draw the picture and think about it logically. If the two of these angles together should add up to 180, if they're supplementary, basically, I should be able to subtract my reference angle from 180. There's a lot of things in pre-cal you have to memorize. So as much of it that you can draw out and it makes sense, the better. Okay, 180 minus 57.995. Type this in, and then we'll check our work. Okay, 122.005. Let's see if when I take cotangent of it, if I get the decimal or the ratio that's written there, and I do, and I know my answer is between 90 and 180, so I know I have I have a good answer. And with that, the lesson's over, which is a good thing because my voice is about to go out.